Okay, guys, good morning. Today we are going to continue on chapter 4. We're going to be talking about patterns and linear functions in 4-2. Luckily, I would say I'm like probably 80% of this lesson we already discussed yesterday. We already learned this yesterday. So this is just going to be a nice review and then some application to what we learned. First of all, before we get into what a linear function is, hopefully you remember what just a plain old function is. A function is a set of values where you can only have one output, one y variable, for every input x value. You can only have one y for any given x. Okay? We went over that yesterday. As far as the x values go, the x values are known as the independent variable. They're known as the input values. And they're also known as the domain. The y variable, or the y values, are known as the dependent variable, the output values, and the range. Those are names given to the y values. So x is independent, y is dependent, and a function is a set of values where you can only have one output, one y value, for any given input or x value. Okay? So all of this should have been in your notes yesterday. Now, a linear function, okay? A linear function is a function whose graph is a non-vertical or part of a non-vertical line. Now, before we get into the intricacies of this linear function, I want to give you some facts first and a little trick to determine whether or not something is a function, okay? First of all, when we're talking about a linear function, guys, and I promise we're going to get into this formula in huge detail next chapter. I mean, you're going to live and breathe this formula for a long time in this class. But we're not going to get into it completely today at all. All I want to show you is the following. If you are ever given an equation with a y and an x, or two variables, and the variables have a power of 1, then you have what's called a linear equation. Look at this x here. What's the power of that x? A 1. It's invisible, right? There's an invisible 1. Remember what we talked about, guys. Every single variable on Earth has a number 1 being multiplied to it, a 1 being divided, and a power of 1. How does that work? What's 1 times x? X. What's x divided by 1? What's x to the first power? X. So, that x there that's by itself, right here, I'm going to circle it now in green, that has a power of 1. Whenever you have an equation with an x and a y, an independent and a dependent, and the independent variable has a power of 1, and the dependent variable has a power of 1, we're talking about a linear function. Now, do you guys remember yesterday, and just 2 seconds ago, when I said that a function is a line or a set of values where you only have one y for any given x, right? I'm going to illustrate this for you with the vertical line test. Let's suppose that I had the following graph. Granted, that's not a line, I understand that, but just bear with me. This is a graph, okay? The vertical line test allows you to determine if if a graph is a function by simply drawing a vertical line, literally. If I take the vertical line here at this value of x, which is 3, at this value of x, which is 3, if I draw a vertical line, how many different y values does it hit? 2. Doesn't it hit here, which is one y value, correct? And doesn't it hit here, which is a different y value? Are you allowed to have two different y values for the same x in a function? That's why the vertical line test is so awesome. Now, I have a little pencil here because you guys can use your pencil to determine whether or not a graph is a function using the vertical line test. For example, let's say, guys, I give you this graph right here. Okay? Let's take my vertical line test. Let's take my pencil. You could draw a straight line, but you could do it with a pencil. Okay. At this x, how many y's does it touch? 1 right here. Actually, let's do it in blue. It's kind of hard to see red on red. Okay? At this, crud. Hold on. Let me go back. Hold on, let me go back. Let me do this the right way. Okay, there we go. That's how I'll just go back and forth. At this point of x, how many y's do I hit? Okay. At this point on the graph, how many y's do I hit at that x? 1. Do you see what I'm saying? Is this a function? Look, when I have this pencil here, doesn't the pencil hit the graph only at one spot? So there's only one y for this given x. The x is down here, guys. Okay, this is the x right here. There's only one y for this given x. You can only have one y for any given x. Does that make sense, guys? Okay. What if I gave you a circle? Will that pass the vertical line test? No. How many y's do I hit here? A y there and a y here. How many do I hit here? 2. This is the x-axis and that's the y-axis. The graph is the circle. You hit 2. So this is not a function. What if I give you this? Does that pass the vertical line test? Yes, 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 yes. Every time I put the vertical line test, it only hits the graph at one spot. So that means there's only one y at any particular given x. Does that help you guys understand the definition now a little bit better? Yes? Yeah? Does that make it a little easier to visualize, you know? So for example, if I had just a bunch of little mini graphs here, let's just put some mini graphs just so I can show you. Okay? Just some mini graphs. Okay? Is this a function?
Yes, sir.
Yes, it passes the vertical line test. Is this a function? No, because right here you have 1, 2, 3 different y values. Good. Is this a function?
Yes, sir.
Now, pay attention. Is this a function? No, very good. If I do the vertical line test here, check it out, guys. Here's my x. But don't I have a y here and a y here and 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 here? I have infinite different y's for the same x. So is that a function? Now, with that in mind, now let's read this definition. A linear function is a function whose graph is a non-vertical or part of a non-vertical line. So a linear function is basically any straight line as long as it's not vertical. A vertical straight line is not linear. It's not a function at all. Sir. Hold on, guys, one at a time. What, my man? Okay, what's the problem? A vertical line is not a function. A vertical line is not a function. Look. If I go ahead and draw a line here on this x, don't I have, for this green x value, don't I have a y value here and here and here, 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 and here. Don't I have like just right there like 15 different y values for the same x? Can I have that as a function? No. So this is not a function. This is not a linear function either because it's not a function. A linear function is any straight line as long as it's not vertical. A linear function is any straight line as long as it's not vertical. I can have that, and I can have this. No. Well, it's a little bit of angle. That's a little misleading. I can have this. I can have this. I can have something straight across, horizontal. That works. I can have something going this way. Any straight line is a linear function as long as it's not vertical. This would not be. It would not because of this part right here. Look at all the different y values that I have for that same x down here. Sir? No, it cannot be curved. It has to be straight. Thank you very much. Linear functions are straight lines that are not vertical. Sir? They're curved. That's not a linear function. Okay, maybe I'll try to say it in a different way. A linear function is a straight line, like a pencil. It's straight. It is a linear function as long as it is not vertical. No curves are allowed in a linear function. There are plenty of curves in different functions, but a linear function is a straight line that is non-vertical. Does that help you, sir? Thank you. Okay, now, the important part of the lesson, okay? We got to talk about how to recognize a linear function. First of all, we can tell this is a function because I have no repeating x's with different y's, right? If I had, for example, a 1 and a 12 down here, automatically, would that be a function? No, because I have two different y values for the same x. You feel me? Okay. Now, so we know this is going to be a function. Now, let's determine if it's a linear function. We have, bless you, we have already done this before in chapter 1 when we were talking about patterns and tables to begin with. What did I do to 1 to get to 2? Added, okay, someone just said add 3. Think about it, man. To get from 1 to 2, how did I add 3? Let's think about these things, guys. Add 1. How do I get from 2 to 3? How do I get from 3 to 4? How do I get from 4 to 5? Okay. Now on the y, on the output side, on the dependent side, how do I get from 8 to 3? I mean 11. How do I get from 11 to 14? How do I get from 14 to 17? And how do I get from 17 to 20? Okay. Now, in order for there to be a linear function from a table, the change in y divided by the change in x must be constant. So let's look at it. What's 3 divided by 1? 3. What's 3 divided by 1? What's 3 divided by 1? What's 3 divided by 1? So this is a linear function. When the quotient of the change in y over the change in x is equal for all sets of values, you have a linear function. Sir? You sure, my man? Thank you. Sir? That's exactly right, sir. You want to find the change in y first. These are the changes in y. Plus 3 for every one in this particular case. And then you want to divide each change in y by, bless you, each change in x. If you have the same fraction for every set, you've got a linear function. If not, you don't. You may still have a function, but it just may not be linear. Okay? So you had a question?
Does it have to pass through more than one quadrant for it to be a linear function?
No, it does not have to pass through more than one quadrant, sir. Thank you very much. Actually, this will pass through more than one quadrant. This is just 5 points of a line. Lines are made of infinite points. Sir, my brother.
So you have to find out what's being added or what's subtracted.
Correct. You want to find the change in y from one value to the next, my man. How did I get from 8 to 11? I added 3. And then you want to find the change in x, too. How did I get from 1 to 2? I added 1. And then you divide each of those changes. If you have the constant same number for each, you're golden.
What if it's
What if it's multiplying? I don't understand what you're saying. Oh, like if this was like 8 and then this was 88 and you had to multiply by 11, it's not going to be a linear function because you're not adding. But that won't happen like that. You'll have different levels. There's a way to check for what's called quadratic functions and for cubic functions. But right now, let's just learn to walk. Just find the first change. If the first changes in y divided by the first changes in x equal the same quotient, then you have a linear function. Sir.
Like, instead of 5.
Okay. What he asked was, instead of the 5, what if it said 6? We're going to do that in green. And then instead of 20, it said 23. Okay, check it out, my brother. It's actually a good question. How do I get from 7 to 23? Plus 6, right? How do I get from 4 to 6? Plus 2, right? What's 6? Come on, stupid. That's plus 6. What's 6 divided by 2? It still works. Thank you. It's actually a great question. Sir.
what if it's like add 2 different types of things?
Yeah.
Like if there's 2 different types of adding patterns.
Okay, we just finished saying that, but I'll repeat myself again. There are different ways to check for different kinds of functions. If you have to find the second change, then you're looking for a quadratic function. If you're analyzing the third change, then you're looking at a cubic function. But for the fourth or fifth time already, we are dealing with linear functions. So with linear functions, we are just looking at the first change. Okay, guys? If that still is confusing, rewatch the video at this point, because I'm not going to repeat myself again. Now, let's try these. Example 2. What did I do to 0 to get to 1? And then? Okay. What did I do to get from 5 to 8? And then? So is this a linear function? Okay. What did I do from 1 to get to 2? What did I get from 2 to get to 3? What did I get from 3 to get to 4? What did I get from 1 to get to 4? Then? Is that linear? Why? Very good. You have 3, then 5, and 7 as the quotients. They're not the same. They're not constant. That's very good. So that is wrong. Okay, how about if we're talking about money? Let's say we're buying cans, okay? A number of cans, that's the X, that's the independent. I can buy 0, I can buy 100. And the total bill, total bill is dependent on how many cans you buy. Okay? If you buy 0 cans, you 5207, that means that you have other items in there, guys. 1 can is 5336, 2 cans 5465, 3 cans 5594. Let's see if this is linear. What do I do from 0 to get to 1? And then? Okay. What do I do to 5207 to get to 5306? That's adding 129. Very good. And then from 5336 to 5465? Plus 129 again. If you don't know how to do the subtraction here, guys, I'll help you out, but you better figure this out. You got to take the larger one minus the smaller. And that's 9. That borrows. And that's a 129, okay? If you're having troubles with that, that's something you may want to look into. And then from 5465 to 5594 plus 129. So is this a linear function? Yes, it is. Does that make sense, boys? Promise? Okay. Now, let me just give you, I thought we're going to finish up with that one, but let me create a couple more. What if I go like this? Okay. What's the change from 0 to 2? 2 to 4? 4 to 6? 6 to 8? 9 to 13? 13 to 17? 17 to 21? 21 to 25? Is this linear? Yes. What's 4 divided by 2? And then 4 divided by 2, then 4 divided by 2, and then 4 divided by 2. And that's linear. Does that make sense, gentlemen? Any questions on this? Awesome. Thank you, guys.